All right, we're going to start with chapter 2 now. Chapter 2 is all about integers. So what I want to start with is a Venn diagram. So this Venn diagram is made up of a series of different type of numbers that exist in what we call the number system. So we have these circles right here, and then they're all within this box. So the smallest group of numbers is right here. Those are your natural numbers. Natural numbers are numbers like 1, 2, 3, and so on. The next group of numbers are what we call whole numbers. Whole numbers are just like natural numbers. So if you look at the Venn diagram, whole numbers include all the natural numbers that exist. There's only one difference. It includes 0, 1, 2, 3, and so on. The next group of numbers includes all the natural numbers. It includes all the whole numbers and their opposites. Those are your integers. So integers are whole numbers 0, 1, 2, 3, and their opposites, -1, -2, and so on. So opposites. Notice in all three of those, there's no fractions and there's no decimals, okay? That occurs when we say rational numbers. Rational numbers are all the numbers that you can think of. They're fractions, they're decimals, they're whole numbers, they're natural numbers, they're all of these numbers. So it's anything that can be made into a fraction is rational. Over here is what we call irrational numbers. Those are numbers that go on forever and ever. They don't repeat and they don't terminate. The only number that I can think of right now that you might be familiar with is pi, which is a number that we use when we're finding circumference or area of circles. And it goes 3.14 and it goes on forever and ever and ever. It never stops. It never repeats. That's irrational numbers. Some other kinds of irrational numbers are like the square root of 2, the square root of 3. These are non-perfect squares. And that square root's something that we're going to talk about more when we get to chapter 9. But for now, just understand they're non-perfect squares. A perfect square would be like the square root of 4 is equal to 2. The square root of 9 is equal to 3. You catching on to this? The square root of 16 is equal to 4. So square root is taking what two numbers of the same number multiplied together create those. These are perfect squares. These are rational numbers. They're integers, they're whole numbers, they're natural. These numbers, like the square root of 3, nothing times itself equals 3. The square root of 5, nothing times itself equals the square root of 5. These are irrational numbers. So if I just grab my calculator and show you, we have the square root button right here, right there. So I would hit second square root, and this, let's do the square root of 25. We know that to be 5. But if I did the square root of 6, I get a number that goes on. And the calculator can't go on forever, so it stops. This is an irrational number. This is a natural number, a whole number, an integer, and it's rational, okay? What's inside the box? These are all called real numbers. What's outside the box is you'll learn in the future. These are imaginary numbers. But our focus today is on integers, right here. So integers, remember, are all positive and negative whole numbers, Okay? So we're going to start with 2.1, which is integers and absolute value. So basically, we're just writing integers right now. So you're just going to write an integer so you can know how to represent it. So 32 feet underground would be negative 32. After 8 weeks after birth would be a positive 8. And a loss of 6 pounds would be a negative 6. Now, remember, when you write a positive, you don't need to have the symbol. You just write the number and it's assumed to be positive. Write an integer for each situation. Again, there's a loss. It's above, so it would be positive, and it's decreased, so it would be negative. So it's just getting familiar with the language at first. So write two inequalities involving 7 and negative 4. So you have 7 and you have negative 4, so you would say, first of all, remember an inequality is less than, greater than some symbols. So you can say 7 is greater than negative 4, or you can say negative 4 is less than 7, like that. Remember, negatives are always less than positive, and always remember that negatives go left, positives go right, okay? So negatives go left to the 0, positives go right of 0. So two inequalities for this one would be negative 2 is less than 3, or you could write 3 is greater than negative 2. So two inequalities for this. You could pause it and try to do this on your own, and then I'll give you those answers. The height of the temperatures for the first 7 days in January, you want to put these in order from least to greatest. Remember, the further left it is on the number line, the further or the more less it is. So remember, further left is less. Left is less, left is less. So put those in order. You can pause it and try it. This is what it would be on a number line, and this is what you would want to write. Same with this, put those in order. There they are. This negative 9 is furthest left, so it's the least. 12 is further right, so it's the greatest. Absolute value is a distance a number is on a number line. So basically all I'm saying to you is, if I'm at positive 5, how many jumps does it take to get back to 0? 5 units. Absolute value symbols are just two elongated sticks like that. Sometimes when I write it, I slant them a little bit so you can see that it's absolute value. It's not the opposite, so don't get confused. Absolute value is just the distance a number is to 0 on a number line. Absolute value is never negative. There you go. The absolute value of negative 8. So when you're doing order of operations, you need to do absolute value first. It's even before parentheses. So it's actually a PEMDAS. Remember that from chapter 1. So a PEMDAS means do the absolute value first. So this says take the absolute value of negative 8 plus what's the absolute value of negative 1, meaning how far is it to 0 from the number line, and then do your math. Okay? Just like that. Absolute value of 6 is 6. Absolute value of negative 4 is 4. And then just do 6 minus 4 is 2. That's it. Absolute value of negative 9. You could pause it right here and try these yourself. Here's your answers. Hopefully this one makes sense to you, because you're taking away more than you have, so you're going to be in debt. Evaluate this. Remember in chapter 1, we evaluated algebraic expressions. Algebraic expressions simply mean there's a variable involved and you're going to substitute. So once you substitute that negative 2 in like this, then you take the absolute value. And because I'm taking away more than I have, I know that I'm going to be negative 6 in the whole. Think of it as like I have $2, take away 8 of your dollars, that means you're going to owe $6. So evaluate that. 5 minus 9, -4. That's it. Chapter 2.1. Good luck.